Hello YouTube, RJ. Today we're going to pick up where we left off in the HP 428B restoration video. Alright, we're back. I've hooked back up onto the 272 volt section of the power supply output. Still got Q1 grounded as required. I brought the power up to 101. Let me bring it up to 103 volts. 103 volts. And we got 272.8. And we're looking for it to stay within 2 volts, going to 127 volts. Here we go. There we are. Rock stable. So we're good there. Don't need to worry about that. The next test is oscillator head drive amplifier. So let me pause, research this, get what I need set up, and I'll come back and we'll try that. All right, we're all set up. I've got my scope set up over here so I can look what we're looking for. Let me see if I can capture it in this. We're going to be looking at test point 3 right here on the paper. And it shows a kind of distorted waveform. And it looks like it's telling me, I don't think it's doing peak to peak. It's either 6 volt peak to peak or it's 6 volt peak. So anyway, that's what we're looking for. See what we get on the scope when we power up now. Here it comes. We're only getting like 2.16 volt peak to peak. I mean, we're getting a distorted wave, kind of looks like that. But nowhere near the voltage they're calling for here. Let's see what it says. Okay. For the schematic test, check the waveform at test point 3. If the waveform is correct, go to 531. If not, go to step B. B says check the signal on test point 2. Okay, that's fine too. Turn this off. I forget that it's on. Test point 2. Okay, it's over here by the oscillator. Looks like they're looking for a sign with a peak to peak of 18 volts. So I've got to find where this is at. It's R93. It's off of V7. So literally we actually want to connect to pin 2 of V7. I'll put the spotlight on it. There's V7 right there. And we need to be on pin 2. So let me move my probe. Find a new ground over here somewhere I can connect to. Okay, pin 2's got a resistor right there soldered to it. That'll work for me. Powering up. Nothing yet. Oh, bouncing around. There we go. We're getting a signal now. So yeah, we've got a lot more signal there. Let me get it adjusted where I can see. We're getting 20 volts peak to peak, perfect sine wave. So we're getting a little more than what they're asking for. The signal at test point 2 is not correct, check V7. If the signal at test point 2 is correct, check V8. If V8 is replaced, perform step 16 through 19 of the adjustment procedures. Well, I've went through all the tubes and I've made sure all the tubes are good. And I did replace one. I don't remember which one. I don't think that's one I changed, but still. It does say that waveform 4 should be the same as 3, except 180 out of phase. So let's look at 4. Let's just take a look at 4. So we've got a good oscillator at the right frequency, or pretty close to the right frequency. So this should be the other side. Should be the same thing, just 180 out. This is the one that we were only getting a little over 2 volts. I have to turn the voltage, scale voltage down, because there we are. That one I'm getting a lot larger voltage and it's bouncing heavily. Oh, there. Helps we get to the ground. Now see, that one's got 7 volts. Interesting. This one's got 7 volts, but the other side, swap over. The other side has hardly any voltage. That makes me think probe problem. I'm thinking this probe is my problem. Probe grounded out where I repaired it or something. Because why would one side be one of a transformer and the other be other unless they're just a... It's interesting, without the probe you get no signal. Well, you get a little signal. Get kind of more of a sine wave. What do I get on this other one? You have a good ground, right? Here, let me do this. I know I'm getting a good ground there. Let me move this from here carefully because I'm still powered up. Yeah. No, it ain't going to be the probe because the probe's disconnected. Probe disconnected, I'm getting the same voltage, but I'm getting a lot less voltage here. And these should be identical, just 180 degrees out of phase. I think what I'm going to do, let me hook up another probe. I'll set it up where you can see it. And I'll give you a shot of the screen. You can see what I'm running into. So I'll be right back. All right, I got 2 probes hooked up on both of those. I'm going to show you here. Let me show you what we're working with on the diagram here. We're testing at these locations right here. This is going out to your probe. Here's your probe. This is your probe connector. And this is your drive. This should be your 20 kilohertz drive. And they should be 180 degrees out. They should be around 6 volts, peak to peak. And this is what I get. Give it a minute to warm up. Look at the differences in the voltage peak to peak at the bottom of the screen. But you can quickly see that we're talking a massive difference in the signals here. Look at the volts peak to peak for channel 1 and channel 2. They're not putting out the same amount, and the probe's not plugged in, so it's not a probe issue. So that's kind of good because I can't get another probe, but I can get work on this device. So I'm going to do a little research. Let's see what it says. It says, if the signal is correct, check V8. If V8 is replaced, perform steps 16 through 19 of the adjustment. Waveform form should be similar, except 180 out. Doesn't tell me why. So I'm going to have to start. Doesn't tell me what to do other than that, it thinks something's wrong with V8. So see, 2 is if the signal at test point is not correct, check V7. Okay, so V7. So V7 is what I need to be looking at, it says. So I can recheck V7. Kill this. I can do that. Let me get let me recheck V7, make sure it's reading good on the tube tester, and then we'll start looking around that area for anything that might be causing this problem. So okay, I've looked at this from a bunch of different angles, and here's what I've come up with. Since we've got good signal on one side of this transformer output from the oscillator down here in the amplifier, the head amplifier is putting out a signal, a good signal we know, at least on the one side. There's a drive amp balance pot, which I played with and had no effect whatsoever. Either we've got a problem there, something being opened or whatever, but a thought hit me as I'm looking at this 12AU7 tube, and I tested all these tubes, and I think I pulled a dum-dum. All these other tubes are, single element tubes. This and the V7 are dual, and I only tested one side. So what's the chances that one side is either much weaker or dead, and almost dead, and that's why we're getting a strong signal to one side and a weak signal to the other? And I just missed it when I was testing tubes because it's been a long time since I tested tubes, and I kind of forgot that you have to pay attention to the tube, whether it has more than one element in it. And so let me test these 2 tubes again, check both sides, and see if I don't find a problem there. That's probably where my problem's at. Okay, check the tube. Not much variation in the 2 sides of the tube. Tube tests good. This tube tests good. So I got to looking in the balance circuit right here, if you can make that out. Kind of small, but right here, we've got a resistor coming off of a 12-volt line. It says it should be plus 87 volts right here. I tested it and it was spot on. I mean, it was exactly 87 volts. Goes into the center wiper of this pot, which is the drive amp balance, which is one of the big pots over here on the bottom. I don't know if you can see them or not. Well, around here you might be able to. Right here's the drive amp balance, which doesn't seem to have an effect. What it should be doing is it should be affecting how much signal, changing the signal amount, like a balance on a stereo between these two. And I don't see any effect happening at all. So that made me wonder if, one of these sides just wasn't getting enough, grid. So I've hooked up the oscilloscope on 2 and 7, and I am getting a perfect 180-degree out of phase signal that is identical. They're within 1/10 of a volt. They're 12.7 and 12.8. So this is getting driven the same. Unless this tube is testing good and really isn't, what I'm going to do now is I'm going to power it off and move over to 1 and 6 and look at the output coming out to see what's going into this transformer and see if we see a balanced signal out of here. If we do, then we've got a problem with this transformer. If we don't, then I'm going to wonder about this tube. I'll check this capacitor just to make sure it's not causing a problem, but I don't know what it would do. Seems like if it shorted, it would take both of them down. If it went open, it wouldn't have an effect at all. But so I'll check that if I've got an imbalance here. Let me get set up, check that, and we'll see what we come out with that. Whether pin 1 and 6, whether they look balanced. So it's going to be a much higher signal, 12 volts. But I'll be back. Okay, I set it up, and sure as the world, we are getting that different amplitude of signal out at this location. So I'm thinking we've got a 2 problem here. I don't think I've got another 12 AU7 on hand. Seemed like I did have one. I don't know where I put it, but I can hunt a little bit. But I'm thinking that's what it is. But I am going to go ahead and check this capacitor. And so I'll lift the leg on this capacitor and fire up the LCR and make sure that it's looking reasonable. Let me check that capacitor. I'll let you know what I find, and then it's going to be trying to find a 12 AU7. So, okay, here's where we're at. Here's what I've figured out. Let me see if I can get this up here where you can see it decent. I'm right now clipped on to 1 and 6 of V8. That's the output of the amplified signal going into the transformer T6 that then goes out to our probes. And if you can see the scope back here, we've got a perfectly even, darn close, 142 volts peak to peak on one side, 140 on the other. So, I mean, we're talking right there. The problem comes in, I'm going to come off the tube now. Let me be safe. I'm going to turn this off. I'm going to move my probes to, I went ahead and got the wires off of the plug up front for the probe, for the probe, the connector for the probe. So these wires go up the connector of the probes where we've been trying to measure. And so I'm going to get a good ground here on with that probe. I'm going to take this probe, get him loose, take him off that ground, get him hooked on here. Let me try to find here's a ground right there to work good. Okay, so they're hooked up, both on, they're both there. I'm going to have to change the scale of the scope down to 2 volts on both channels because the voltage is much lower when it comes out of the transformer. Okay, so now we're looking at where I just tested runs straight into one side of the transformer, runs into right here into this transformer. I did check the capacitor, as I said. The capacitor is fantastic, right on spec. ESR looks fantastic. Soldered the leg back down. So we've tested across that capacitor right there, and we've got what looks great. Now what I've done is I've literally jumped over to the orange and the orange white coming off, which would go to the plug, but I've got it disconnected at the moment. And we should see around 6 volt peak to peak, 180 out. Same signal we saw here, just reduced down to around 6 volts. So let's see what we get. Give it a minute to warm up. There it comes. And we don't. Let me reach over here and get this thing triggered. Let's trigger off of 1. There we go, that's better. And as you can see, we've got a dramatically lower output on one side. And make sure my grounds are good and I don't have a grounding problem. But I do have a signal here. If I change the voltage on channel 2, you'll see that there is a signal in there. It's just much less. Just barely got a signal. So my ground's not good there. It's looking more like it. There's 200 millivolt scale. The other's on 2 volts. So you can see we're talking 10 volts peak to peak and half a volt peak to peak. So something's going on there. So what I'm going to do is, if you look at this, I get this back in here. It's in focus enough for you guys. If you look here, you've got one of the wire comes off. That's where the currents for each side is going to. Okay. There's really no reason why these would be dramatically different. So I'm going to go ahead and remove the blue and blue-white from the tube, the red from the circuit board. I'm going to pull that transformer out. Let's put an ohm meter on it, kind of check it out, see if it looks odd, like it's maybe something's not right, and then we'll go from there. So I will be back. Okay, I'm back. Let me tell you what I've done. I took this out, put the ohm meter on it. Actually, I put the LCR meter on it, checked for ohms, checked for inductance. And what I found was if I look at the blue wires here, the blue to the blue and the white, I got 185 ohms and 82 millihenries. When I look at the blue to the red, I get 78 ohms and 15.4 millihenries. When I go to the blue and white to red, the center tap, I get 107 ohms and 17 millihenries. So there's a little bit of a difference there. I mean, that's, well, it's not a little bit. It's like over 25%, right? Nothing shorted the can. When I go to the orange, it's a single winding, 2.6 ohms, 76 microhenry. I can buy that. Again, nothing shorted the can. Center tap, nothing shorted the can. I don't know what would make such dramatic differences in the voltages on the outputs. Definitely getting the same input here, but getting very different outputs here. Just, the other thing is, where's this resistance come from? If this is just an inductor with coils, you wouldn't expect this much resistance. You'd expect something like this. So I'm assuming there's more to it than that. So then I got my little peak DCA 75, component tester out and thought, well, let me do this. Let me hook it up here. Actually, let's start here. If I go over to the orange, the outputs, and I check that winding, which should just be a coil winding, I would expect, tells me it's shorted. So 2.6 ohms is too low a resistance for it. It just says they're shorted. If I go to the blue and hook up the blue windings, and there's no short, by the way, between the blues and the orange. I go here and test again. I get a diode junction, 0.935 volts at 5 milliamps. Okay, interesting. So let's swap it around. Diode junction there. Just come up and tell me diode junction, just the leads flipped, right? Now it says it's a Zener diode at 0.937. That's odd. Why am I getting diode and then Zener diode the other way around? So then I thought, well, what happens when I look to the center tap? So let's go to the red here. There's no component. It says there's nothing there. Here and test. Now I've got a diode junction. So I've got a diode junction to the red from the blue to white to red. I've got no component. I got a diode junction one way on the blues and a Zener diode the other way. Anybody explain that one to me? I don't know. I'm befuddled at this moment. I think my problem, at least with this issue, maybe there's other issues in the meter, but definitely this has to be resolved. This will never work right this way. I'm thinking in this can, and the thing about it is, if we take a good look in there, it's potted. Don't know where I get one of these without buying another meter. I'm not buying another meter. The other meter is a much newer meter, does not use this transformer. So that's where I'm at. If I can't get anywhere with this, I'll pull this one off the bench. I'll put the other one on the bench, start working through it, and see if I can get it up and running. So that's the one that came with this probe. So anyway, that's where we're at. I'm going to end the video here. Grab some lunch, like I said, think about what I'm going to do, and we'll pick this back up in the next video. So hey, thanks for hanging out with me, having fun on the bench today. I hope you enjoyed it, and most of all, hope to see you in the next video.